Hi everybody, in this video I'm going to talk about file-based systems and I will compare them to database management systems. Database management systems is one of the most important uh, technologies that we have. It's a really important field in software engineering. The reason for that is pretty much all technology, uh, any organization that has anything to do with data is using database management systems. It's currently the modern way to store data, make use of the data. They were not around until 70s, and before that, companies and organizations they used file-based systems. File-based systems are the first approach to computerizing actual file systems, physical file systems here. I'm talking about papers and cabinets, and back then this was the traditional way of storing data, right? If you had a company, if some client made a purchase from your company, they would fill out a form, they would fill out paperwork, or your accountant would file the paperwork, how much was the transaction, how much you got paid, or the date, who bought it, etc. This would go into a paper, and it would go into a cabinet, right? And usually, this type of traditional systems had a organization way of organizing files. For example, you could organize your files based on uh, in alphabetical order, or based on sale date or some other date, or amount of sales, or by clients, etc. And you could use one parameter to save these files in your file cabinets system. And security is also an issue because then you would have to physically store them in a safe environment where uh, you need to make sure they don't get wet, there's no fire risk or anything like that. And also it's more difficult to copy physical files, right? So if you have one file cabinet and that gets burnt, let's say something happened, it got burnt, and you lost all your data, all your company data, your company's operations will come to a halt. Alternative is that you would have to make copies of the physical files and have another location where you store the same files. But then you would run into problems such as what happens if the data gets updated, right? Maybe some of the files, some of the sales got an update, prices changed, and then how do you go? So now you have to go to the other side and update the file there. Otherwise, you have data inconsistency. So traditional file systems were a bit of a problematic. Then actual file-based systems, the first attempt to computerize traditional file systems, was basically just writing programs that uh, save these files in computer systems. So instead of storing them in a cabinet, now you would start to store them in computer programs, computers. Let's talk about some of the issues that come with file-based approach. First one is separation and isolation of data. In these systems, data tend to exist in different files, different programs. A lot of times there are different programs for different purposes. You don't have one central program that handles data centrally. A lot of companies back in the day had programs for each of their department, for their different departments, such as client relations management department may have a program that stores their data, sales department can store their data, or HR department can store their data. And the problem with this is that sometimes you may need to do cross-referencing, right? So you may need to compare certain data with some other data, and if these data don't exist in the same place, same program, this can become costly, or you may end up writing programs that are used maybe once, and this is a costly approach because then you would have to hire people to deal with this, and it's not a sustainable way to go. For example, you have a real estate company and you have a client, and the client has certain requests, certain type of house he's looking for, with certain amount of rooms, certain amount of uh, maybe a certain type, such as a flat or is this a family house, and a certain rent. He has a maximum rent, minimum rent, and you also have a list of properties. And in a file-based systems, it's really difficult to search, cross-reference these type of queries, right? Because you have to take the customers, the clients' preferences, and you have to compare them all to all different um, properties, and that has the rent less than client's maximum rent, that has the type that is the client's preferred type of the property, etc. And you may have to compare two files to get the correct set of properties. But if you need to, in some cases, you may need to synchronize more than two files, and this becomes really ineffective. Next problem is duplication of data. In business of storing data, duplication of data is one of the worst things that can happen. Basically, it's storing the same data more than once in different parts, different places, and it will be caused by decentralized approach. It will definitely result in duplicate data. And why is it bad? Because it wastes a lot of space, a lot of storing data is a costly thing. You have to have servers, you have to have or physical storage, and this physical storage, consumes resources. And when you store it there, it costs you money. If you have a lot of duplicate data, millions of data, then it becomes really costly. And more importantly, it causes data inconsistencies. Let's say you have same data stored in two different places, you have duplicate data, and you make a change in one of them, one side, and the other side you don't make a change. Now, there you go, you have data, inconsistent data. You don't know which one is correct. For example, your company has a payroll department and HR department, where payroll department makes sure employees get paid. Let's say you have an employee, he moves to a different place, he lets HR know, but he doesn't let payroll department know. Now, HR updates his address, payroll does not update his address. He keeps getting paychecks to his old address. Now, it's again costly because somebody has to sit down, fix this error. They have to make sure which one is the correct address or not. Okay. So the application of data is another problem. Next problem, some other problems are data dependence. Data dependence basically is about the structure of the file structure defined in the program code. And different programming languages, depending on which one you use, may create different file structures, and that actually limits the future add-ons to the program. If a program was written with C, it would have a different file structure than a program written in COBOL. And if you start with one, you would have to stick with that one, and then this could also become costly in time. It's also difficult to make changes in the existing structure. If you have a field, let's say a name field with 40 characters, to do 41 characters, you would have to require making changes to the structure of the program. And fixed queries, proliferation of application programs, programs written to satisfy particular functions. A new requirement needs a new program. So every time you need to write a different query, a different type of report, then you have to write a new program. You have to bring in an application developer here to write something new. And it's also not very efficient way of approaching. Now, these are the problems that database management systems address. First of all, the most importantly, they centralize the data. Okay, so you have data in one place, and everybody accesses and uses data from there.